Let's see what happens when we take powers and raise them to other powers. But first, can you evaluate 4 to the third power? Right, 4 to the third power is 4 times 4 times 4, which equals 64. Now what happens if we take 4 to the third power and then raise it all to the second power? Well, squaring 4 to the third means we're multiplying 4 to the third by another 4 to the third, and this product is 4 raised to some power. What's the missing power or exponent over here? So if you're multiplying 4 to the third by 4 to the third, how many 4s are you multiplying all together? Right, when you multiply powers with the same base, you can add the exponents. So 4 to the third times another 4 to the third is 4 to the sixth power, because 3 plus 3 equals 6. Let's look at another example. Suppose you're raising 2 to the fifth power, and then you raise that to the fourth power. So that's 2 to the fifth times 2 to the fifth times 2 to the fifth times 2 to the fifth. This equals 2 raised to what power? Exactly, we're multiplying a total of 20 2's here, so this is 2 to the 20th power. So 2 to the fifth to the fourth equals 2 to the 20th. You might have noticed a pattern here. When you raise a number to one power and then to another power, that's the same as raising it to a single power that's the product of those two other powers. So up here, 3 times 2 equals 6, and over here, 5 times 4 equals 20. Try applying this rule to another expression, 7 to the 9th power, then raised to the 11th power. This equals 7 to what power? Exactly, so the missing exponent here is 9 times 11, or 99. So 7 to the 9th, then raised to the 11th, equals 7 to the 99th power, meaning you're multiplying a total of 99 7s together. Next, go ahead and identify which of these expressions here are equivalent to 5 to the 24th power. Excellent. So these were the two correct answers here, because 3 times 8 is 24, and 6 times 4 is also 24. 12 times 12 is 144, and 3 times 7 is 21, so those do not equal 5 to the 24th. Now here's a challenging question. 3 raised to the 50th power equals 9 raised to some power. Find this missing exponent, or click here if you get stuck. Brilliant! So this exponent must be 25. And that's because you can rewrite 9 as 3 to the second power, and 50 equals 2 times 25. So nicely done. Next, say we're raising 3 to the fifth, and then we raise that to the sixth, and then we raise that to the second. All of this equals 3 raised to what power? And click here if you'd like to review parentheses and brackets instead. Right, here you multiplied 5 by 6, and then you multiplied again by 2 to get a total of 60. So this expression equals 3 to the 60th power. Now one more thing. Say you're raising 2 to the third power. We've always been putting parentheses around these expressions before raising to another power, like the fourth. So because of the parentheses, this means you're first raising to the third, and then raising to the fourth. And this equals 2 raised to the 3 times 4, or 12. But what if we leave out the parentheses? So we have an expression like this, 2 to the third to the fourth. Well, this means something a little different. By convention, order of operations actually says to evaluate the exponent up here before looking at the exponent down here. So first, you'd evaluate 3 to the fourth power, which is 81. So this expression equals 2 to the 81st power, which turns out to be a lot larger than 2 to the 12th. Try a few more examples. Here are expressions with exponents of 5 and 2, but the order is different, and there are some parentheses here as well. For each equation, what's the missing exponent? Great, because of the parentheses here, you're first raising 3 to the 5th and then squaring it. So that's a total of 10 3's being multiplied, and this is 3 to the 10th. You get the same answer over here, raising to the 2nd and then to the 5th. But down here, order of operations says to evaluate the 5 squared before doing anything else, so this is 3 to the 25th. And over here, 2 to the 5th is 32, so this is 3 to the 32nd. So when you're raising a power to another power, pay careful attention to whether there are parentheses. And when there are parentheses and you're raising to the powers one at a time, it's equivalent to multiplying the exponents together.